Okay, in this section we're going to talk about future value of investments, or how you can effectively plan for your future balance in an account. What this means is, suppose you have money to invest, but you need it to be worth X number of dollars at a certain point in the future. How can you make sure that you have enough, or how can you tell what it's going to be worth so many years in the future, depending on what you're depositing and depending on what kind of rate you're earning? So there is this long formula here, which if you look at it and you take away this part, this is the formula that we were using before. 1 plus r over n to the nt power times the principal. So we're just going to be adding a little bit to that to find the future value, or what an account is going to be worth in the future based on a certain amount of years and certain rate. And what we're adding to that formula is we're adding a -1 up here in the numerator. So that -1, and then when we get all that number, we're going to divide it by r over n. So this same calculation here is going to be used in the numerator and the denominator. It's the same variables that we've been talking about. The balance is at the end of the investment period. The P is the principal, R is the rate, N is the number of times it compounds annually, and T is the length of the investment in years. Let's look at a couple of examples. Rich and Laura are both 45 years old. They open an account at Rhinebeck Savings with the hope that it will gain enough interest by their retirement age 65. They deposit $5,000 each year into an account that pays 4.5% interest compounded annually. What is the account balance when Rich and Laura retire? So they're both 45. They want to retire at age 65. So the T number would be 20. You are looking to determine a balance at some point in the future, so this is a future value problem. $5,000 is deposited each year for 20. This is the periodic investment, which is what P is. P is the principal, or the amount that you're investing every period, or periodically, in this case every year. So we're going to use this big long formula, and we're just going to plug the numbers in. P is 5,000, R is 0.045, that 4.5%. N is the number of times it compounds annually, which is 1. To the NT power would be N times T is 20 years, minus 1 divided by R over N. I know it looks difficult, but if you just let your calculator do the work, it's equipped to do that. All you got to do is plug the numbers in correctly and then punch them in the correct order. So, using PEMDAS, we're going to do inside this parentheses first, just like we did before, and then raise it to that power. 1 times 20 is going to be 20. So 0.045 divided by 1, that's that, plus 1 is this whole number. I'm going to raise that to the 20th power, and then I'm still inside this big parentheses. Now that I have that number, I'm going to minus 1. I've done that, and now I have all of this number here, if you can see it on the calculator, and now I'm going to multiply it times the 5,000. 7058.57. So this number comes out to be 7058.57 divided by 0.045 divided by 1. Well, anything divided by 1 is itself, so 0.045. So when you divide this number by 0.045, let's see what we get. 7058.57 divided by 0.05 is 156,857.11, which is what they got there. Okay, so when they retire in 20 years, that's what they'll have. So let's try another one. How much more would Rich and Laura have in their account if they decided to hold off retirement for an extra year? So instead of 20 years, it's going to be 21. So we're going to set it up the same way. $5,000 invested periodically, 1 plus the rate over the number of times it compounds annually, which is 1, all to the 21st power, 1 times 21 now, minus 1, all over 0.045, the rate over N. Let your calculator do the work. Do this number first, raise it to that power, then take away 1. So 0.045 divided by 1, that's this number, plus 1. Now I have this number, raise it to the 21st power. Now I have all of this, take away 1. Now I have the whole parentheses, multiply it times 5,000. 760121 divided by 0.045. In this case, 0.045 divided by 1 is just 0.045. They end up with $168,915.68. So a little bit more just by holding off for a year. 168,915 versus 156,857. Okay. How much interest will Rich and Laura earn over the 20 years? Well, the balance at the end of 20 years was this 156,857 that we found. Rich and Laura deposited $5,000 into the account every year for 20 years. So their interest is going to be what they earned over what they put in. Well, if they put $5,000 in for 20 years, that means they put in $100,000 over the course of that time. What they made was $156,857.11. If you subtract those two amounts, you get $56,857.11. That's how much interest they earn in the 20 years. Now, how much more interest would Rich and Laura earn by retiring after 21 years? Well, in 21 years, we just found that amount, 168,915.68. They made 168,915.68 was their account balance. How much more interest would they earn in retiring 21 years? Well, in 20 years, they deposited $100,000. Well, now they're doing 21 years, which means they deposited that $100,000 plus another $5,000 for that extra year. So what they deposited was $105,000. So their earnings will be simply the difference of these two if you subtract them. So 168, I think I still have that in the calculator, minus 105 is 63,915.68. 63,915.68 is what they would earn in interest by holding off for 21 years. The question, though, says how much more interest would they earn? Well, that's what they would earn in interest for 21 years. What they earned in interest for 20 years was $56,857.11. $56,857.11. So how much more interest would they earn? If I subtract these, that tells me how much more interest they would earn. 63,915.68 minus 56,857.11. So by holding it an extra year, they would earn an extra $7,058.57. That's the answer to the question. So the thing is this formula, I know it looks complex, but just plug the numbers in where they go and follow the rules of PEMDAS, and your calculator will do all the work for you. You just have to put it together.